Okay, in this lesson we're going to look at simplifying radicals. So let's take a look at the warm-up. We have 2x plus 3y minus 7x plus 4y. So if you think back to grade 9, the way we combined like terms was to look at each of the terms, and any terms that had the same base with the same exponent on it, we knew were like terms. And when we recognized what the key terms were, we would combine the coefficients, either through addition or subtraction, depending on what the operation is that's given. So I'll notice here that I have 2x and I have 7x. Those are like terms, so I'm going to group them together. And then I have 3y and 4y as well. And remember, when you're moving the terms, to take the sign that's in front of the terms. Okay? And so if I simplify this, I get 2x minus 7x, which is negative 5x. And positive 3y plus 4y, which is plus 7y. Now, one thing to remember is that when you are looking at like terms, the bases have to be the same, and so do the exponents. And so we're going to apply a similar rule when we're looking at simplifying radicals. So that's the lesson we're going to be looking at today, and you'll see how this rule sort of works with radicals as well. So let's see what a radical is first. So looking at an introduction to radicals. The definition of a radical is, or radical expressions involve the square root of an unknown. Okay, so a value that you're not sure of. The radicand is the expression under the radical sign. So for example, if you have the square root of 2x, the radicand is whatever is underneath the square root sign. So that would be 2x in this case. Okay, some things you should know. There are entire radicals and then there are mixed radicals. Entire radicals mean that you only have numbers under the radical sign. So for example, the square root of 53, square root of 17, square root of a half. The only values that you have are numbers underneath the root sign. Mixed radicals, on the other hand, have numbers before and under the radical sign. So for example, you have 2 root 7, 4 root 3, and then 1 half root 5. So you have a number in front along with a number underneath the radical sign. It's sort of like when you're looking at improper fractions versus mixed fractions. Similar idea. Okay, we're going to look at how to simplify radicals. So we're going to look at the steps you need to take to simplify radicals. So here are the steps we're going to be looking at. First, we're going to express a radical as a perfect square and another number. So for example, if you have something like the square root of 12, what we're going to do is we're going to break up the 12 so that it's two factors. One factor will be a perfect square. The other factor we're not too worried about. Ideally, you want to come up with the largest perfect square factor, but if you don't come up with the largest perfect square factor, it's still okay. It'll just mean it takes you more steps to simplify it, but you can still get the solution, okay, or the answer. So here I would break this up into the square root of 4 times 3. So the perfect square factor I know that goes into 12 is 4, and the other factor that remains would be a factor of 3. Now, if I wanted to simplify this, I can rewrite this as the square root of 4 times the square root of 3. Okay, so the first step is to express a radical as a perfect square and another number. So I broke down 12 into 4 and 3. And then your next step is to take the square root of the perfect square and leave the other factor under the radical sign. So you'll notice that the square root of 4 is something I can actually evaluate, whereas the square root of 3 is something I cannot evaluate. So this will end up giving me 2 times the square root of 3. Okay, so that's the radical in simplified form. So the square root of 12 in simplified form is 2 root 3. Okay, some things you should know. A radical is in its simplest form when the radicand has no perfect square factors except for 1. So if you look at the square root of 3, the radicand part is 3. The only numbers that go into 3 are 3 and 1. There is no perfect square value other than 1 that goes into 3. Okay, or that you can divide 3 by. The radicand does not contain a fraction, so you can't have something that looks like the square root of 1/2. And we're going to look at how to simplify something that looks like this as well. The last part is no radical appears in the denominator of a fraction. So for example, if you have something like 3 over the square root of 2, you can't have that either, and we're going to look at how we can simplify this expression so that there's no radical underneath the denominator, in the denominator. Okay, here's a couple of examples for us to just practice simplifying radicals. So in this case, all we're doing is we're trying to rewrite this so that it's a mixed radical instead of an entire radical. Okay, so we want to rewrite this as a perfect square factor and and another factor. It doesn't really matter what the other factor is. Okay, so I know that I can break up the square root of 54 into the square root of 9 and the square root of 6. Okay, so I know that 9 times 6 will give me 54, and so I broke up the square root of 54. And now I can evaluate the square root of 9 to get 3, and the square root of 6 stays the way it is. Okay, just to check to make sure your calculation is correct, what I can do is evaluate this on the calculator, and the answer I get for the square root of 54 should be the same as the answer of 3 times the square root of 6. Okay, so square root of 54 is about 7.348, and 3 times the square root of 6 is also about 7.348. So I know I did it correctly. Okay, let's take a look at the next one. The square root of 242. Now, if I break this up, I know that 242 can be broken down into 121 times 2. And the square root of 121 is 11. And then the square root of 2 stays the way it is. Okay, so you really need to think about what your perfect square factors are in order to get really good at this. And I know my perfect square factor that goes into 242 is 121. And the square root of 121 is 11. Another thing to remember is that when you are breaking it up into the two factors, write the perfect square factor first, just because you're going to be evaluating that one. And so you want it to be written first so that you can evaluate it and then it's in proper form. Okay, coefficient and then the radical right after. Okay, the next thing we're going to look at is some steps for multiplying and dividing radicals. So that's the next part. So multiplying and dividing radicals. The steps you would take to multiply and divide radicals is that you would place the two radicals under one radical sign as a product or quotient depending on what the operation is. Then I would multiply or divide the factors depending on whatever the operation is. So for example, if you had the square root of 3 times the square root of 15, for example, then I would multiply these two by writing them both under one radical. And because your operation is multiplication, I would rewrite this as the square root of 45. Okay? And then your next step is to do what we did previously and try to simplify this as much as you possibly can. So the way I would simplify this is to rewrite this as the square root of 9 times the square root of 5 to get 3 root 5 as my final answer. Okay? Here are some properties of radicals. If you are multiplying radicals, then the square root of a times the square root of b is equal to the square root of a times b. And it works the other way as well. If I wanted to break it up, much like what I did here, I have the square root of 45 and I can rewrite it as two factors instead of just one. Okay, so you can always work towards getting it under one radical or breaking it up into two radicals. Okay? There are some exceptions to the values of a and b that you can have. They have to be greater than or equal to 0, and that's mostly because you can't find the square root of a negative number. Similarly, when you are dividing, you can rewrite it under one radical and vice versa, so you can work backwards as well and break it up into two radicals. And again, this restriction is a little bit different. You have a has to be positive numbers only or equal to 0, whereas b can only be a positive number. And the reason for that is because b cannot be equal to 0. B can't equal 0 because the square root of 0 is 0, and you can't have division by 0. It is undefined. Okay, so that's why there are some restrictions on the values of a and b. So let's take a look at some examples. So we're looking at multiplying and dividing radicals in this case. So the first one, again, the operation is multiplication. And so I'm going to simplify this by writing them both under one radical and multiplying the two radicands that are underneath the radical sign. Okay, so 3 times 11 gives me 33. And now I think about whether or not I can simplify this. Is there a perfect square factor that goes into 33? In this case, there isn't, so we're going to leave it the way it is. Okay, that's as simplified as it can get. Okay, the second one, our operation is division. And so I have the square root of 45 divided by the square root of 5. And so I'm going to write them both under one radical and divide them out since I can in this case. And 45 divided by 5 is 9, so I get the square root of 9. And a lot of times you forget that you can actually find the square root of 9, and the square root of 9 is just equal to 3. Okay, and so there's the expression in simplified form. Okay. Please be careful. A lot of times, for some reason, students like to write the square root of 3 as the answer because you think a radical sign has to be everywhere. But you know the square root of 9 is equal to 3. And so please don't make that mistake. It's a very common error. Try to avoid being the person who makes that error. Okay, last one. We have the square root of 625 divided by the square root of 5. And again, I'm going to divide these out and write them under one radical. And the square root of 625 divided by 5 is equal to 125. And again, I know I can break down 125 further. 125 can be broken down into two perfect squares. And one of the perfect squares would be 25. And the other perfect square would be 5. Or sorry, the other number would be 5. 5 is not a perfect square. And so the square root of 25 we know is 5, and then the square root of 5 stays the way it is. Okay? So what you really need to do is practice knowing what values are your perfect square values that go into each of these numbers. And if you don't remember what your perfect square values are, just to remind you, you're really just looking at 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, etc., and that continues. And so the perfect square values that you're looking at are 1, 4, 9, 16, 25, 36, etc., These are the perfect square factors that you want to see whether or not they go into the numbers that remain. Okay, so I know 25 goes into 125, so that's the largest perfect square factor that I can pull out of there.